This training is provided by SafeShield. We're a professional training provider that specializes in cybersecurity, compliance, risk management, and AI governance. Our goal is to give professionals the knowledge and skills required to advance their careers and get ahead of the competition. This free course is part of that goal. We want to make trusted, high-quality education accessible and to support the development of responsible practices in new and emerging fields such as AI governance. Transparency and explainability are two of the most critical principles in the governance of artificial intelligence. They provide the foundation for trust, accountability, and meaningful oversight of AI systems. Transparency refers to making the inner workings, design choices, data sources, and limitations of an AI system visible and understandable to relevant stakeholders. It ensures that users, regulators, auditors, and impacted individuals are not left in the dark when an AI system makes or supports decisions. Explainability, on the other hand, refers to the ability of the AI system to communicate the reasoning behind its outputs in clear, human-understandable terms. While transparency focuses on openness and disclosure, explainability focuses on comprehension and clarity. Transparency and explainability are essential to ensure that AI systems are not black boxes, but instead are interpretable, predictable, and accountable. This session introduces the objectives, scope, and structure of transparency and explainability, setting the stage for exploring how these principles are embedded in international standards, such as ISO IEC 42001, the NIST AI Risk Management Framework, and the EU AI Act. Participants will also learn about the risks associated with opaque systems, the benefits of making AI interpretable, and the organizational responsibilities in applying these principles throughout the AI lifecycle. By the end of this session, learners should recognize transparency and explainability as mandatory elements for building trustworthy AI systems. Transparency in AI is a matter of compliance and a prerequisite for trust. When stakeholders, users, regulators, employees, and customers cannot see or understand how an AI system works, it creates uncertainty, suspicion, and resistance to adoption. Transparent systems, by contrast, allow organizations to demonstrate that decisions are based on well-founded methods, quality data, and documented assumptions. Transparency also provides the foundation for oversight. Auditors and regulators need sufficient information to verify compliance with ethical, legal, and technical requirements. In addition, transparency mitigates reputational risks. A lack of openness often leads to public backlash when hidden biases or errors are discovered, damaging both the organization and the credibility of AI as a whole. From an operational perspective, transparency supports continuous improvement by enabling teams to diagnose errors, retrace decisions, and refine models. It also strengthens resilience against malicious use by making assumptions and limitations explicit. Transparency does not necessarily mean revealing every line of code, but it does require providing meaningful documentation, reporting mechanisms, and structured disclosures. International frameworks echo this requirement. The EU AI Act classifies transparency obligations according to system risk levels, while ISO 42001 establishes transparency as a core management system principle. Transparency allows AI to be deployed responsibly, building confidence that the technology serves organizational and societal goals instead of undermining them. Explainability complements transparency by ensuring that stakeholders can see the information provided and understand it. A highly technical disclosure is meaningless if it cannot be interpreted by its audience. Explainability ensures that outputs of AI systems can be contextualized and justified in terms that are accessible to decision makers, auditors, and even the general public. For example, if an AI model denies a loan application, explainability mechanisms must describe which factors influence the outcome, how these factors were weighted, and why this result is consistent with the system's rules. Without such explanations, individuals cannot exercise their rights to contest, regulators cannot verify fairness, and organizations cannot defend their systems in court or public opinion. Explainability also plays a critical role in organizational learning, enabling teams to identify flaws, bias, or unintended correlations in their models. In sectors like healthcare or criminal justice, explainability can literally be a matter of life and liberty, making the requirement non-negotiable. Standards and frameworks are increasingly explicit about this need. The NIST AI Risk Management Framework emphasizes explainability as part of the trustworthiness criteria, while ISO 42001 requires organizations to establish explainability objectives as part of governance processes. Explainability, therefore, is a technical challenge and a governance responsibility. Opaque AI systems, those that operate as black boxes, pose significant risks across ethical, legal, and operational dimensions. From an ethical perspective, opacity prevents meaningful accountability. If no one understands how a system reached its decision, it becomes impossible to assign responsibility or remediate harm. This creates an environment where discrimination, bias, or harmful outcomes can flourish unchecked. Legally, opacity exposes organizations to regulatory penalties, lawsuits, and non-compliance findings, especially under frameworks like the EU AI Act, which mandates transparency obligations for high-risk systems. Operationally, opaque systems undermine reliability. Teams cannot identify sources of error, evaluate robustness, or adapt models to new conditions if the internal logic remains hidden. Opaque systems also create barriers to adoption. Employees and customers are less likely to trust or use AI if they cannot understand it. Furthermore, opaque AI opens doors to security risks, since adversaries may exploit unexamined weaknesses. In critical domains such as finance, healthcare, or law enforcement, opacity can lead to severe consequences: unjust loan denials, incorrect diagnoses, or unfair profiling. Organizations deploying opaque systems risk fines, reputational damage, and erosion of stakeholder trust, which is difficult to rebuild. For these reasons, achieving transparency and explainability is a necessary safeguard against harm. When organizations embed transparency and explainability into their AI systems, they unlock multiple benefits beyond regulatory compliance. First, these principles enhance trust among stakeholders by demonstrating that the AI operates in a clear, accountable manner. Trust accelerates adoption, making employees more willing to use AI recommendations and customers more comfortable engaging with AI-driven services. Second, transparency and explainability facilitate oversight. Auditors and regulators can evaluate systems more efficiently, reducing friction during inspections and certifications. Third, they support continuous improvement, since interpretable models and clear documentation help development teams identify areas for refinement. Fourth, transparency fosters resilience by making limitations and assumptions explicit, preventing over-reliance on flawed or biased models. Fifth, explainability reduces legal risk by providing organizations with defensible evidence in cases of disputes or investigations. Finally, these principles create strategic value. Organizations that can clearly demonstrate how their AI systems work gain a competitive advantage in markets increasingly shaped by ethics and accountability. Transparent and explainable AI becomes a business enabler, allowing organizations to expand responsibly, maintain customer loyalty, and align with international expectations of trustworthy AI. In this sense, transparency and explainability are not costs or burdens, but investments in long-term credibility, sustainability, and innovation. Transparency and explainability are enshrined in major global AI standards and regulations, reflecting their central role in trustworthy AI. The EU AI Act introduces risk-based transparency requirements, mandating disclosures such as the use of biometric recognition, human oversight, and explanation of outputs for high-risk systems. The NIST AI Risk Management Framework identifies transparency and explainability as key dimensions of trustworthy AI, recommending practices for clear documentation, audience-specific explanations and evaluation processes. ISO 42001, the international standard for AI management systems, integrates transparency and explainability as part of organizational governance, requiring policies, objectives, and controls to ensure interpretability across the AI lifecycle. OECD AI principles also emphasize transparency and responsible disclosure to foster accountability and public trust. In healthcare, the U.S. Food and Drug Administration, FDA, demands explainable models for medical devices involving AI, while financial regulators globally require clarity in algorithmic decision-making. Collectively, these frameworks signal that transparency and explainability are not aspirational goals, but binding obligations for AI governance. Organizations must prepare to meet these requirements by embedding disclosure mechanisms, documentation practices, and stakeholder-focused explanations into their AI management systems. Failure to align with these standards exposes organizations to compliance risks and reputational and operational setbacks. Transparency in AI operates across multiple dimensions, each serving a distinct purpose in governance and accountability. Technical transparency refers to revealing how models are built, trained, and validated, including information about algorithms, parameters, and architectures. Data transparency involves documenting data sources, collection methods, labeling practices, and potential biases. Process transparency highlights the design and decision-making processes behind AI development, including governance structures, stakeholder involvement, and ethical reviews. Outcome transparency ensures that the outputs of AI systems are interpretable, with clear communication of accuracy, confidence levels, and limitations. Impact transparency focuses on disclosing potential consequences of AI use, both positive and harmful, enabling stakeholders to assess societal and ethical implications. These dimensions must be tailored to stakeholder needs. Regulators may require full documentation, while end users may need simplified explanations. Standards like ISO 42001 call for transparency policies covering all these areas, while the EU AI Act demands targeted transparency measures, such as user notifications and clear disclosures of system capabilities. Addressing transparency holistically allows organizations avoid treating it as a checkbox exercise and instead build a culture of openness that spans technical, organizational, and societal levels. This approach ensures compliance and supports fairness, accountability, and resilience across the AI lifecycle. Explainability is not one-size-fits-all. It must be adapted to the knowledge, role, and responsibilities of the stakeholder engaging with the AI system. For end users, explainability means providing simple, clear reasoning behind decisions in a way that empowers them to make informed choices or contest outcomes. For developers and data scientists, explainability involves detailed insights into model structure, data dependencies, and algorithmic reasoning to support debugging and improvement. For executives and decision makers, explainability requires connecting system outputs to business goals, risks, and compliance requirements, often through visual summaries or dashboards. For auditors and regulators, explainability entails access to comprehensive documentation, testing evidence, and interpretability metrics. This tiered approach ensures that the same system can provide multiple levels of explanation without overwhelming or underinforming stakeholders. The NIST AI Risk Management Framework refers to this as audience-tailored explainability, emphasizing that explanations must be appropriate to context and use. ISO 42001 aligns by requiring organizations to define explainability objectives that map to stakeholder groups. Designing layered explainability strategies will enable organizations to meet compliance needs and create trust and clarity across diverse user groups, ensuring that AI remains accountable to all those it affects. Organizations can adopt several methods to achieve transparency throughout the AI lifecycle. Documentation is foundational, including data sheets, model cards, and system logs that record design choices, assumptions, and limitations. Open communication channels allow stakeholders to ask questions and receive clarifications about system behavior. Disclosure mechanisms, such as transparency reports and public statements, provide regular updates on system performance and risks. Governance records, minutes from ethical review boards, decision registers, or compliance audits, document organizational accountability. Third-party validation adds credibility by involving independent reviewers to assess system transparency claims. Traceability tools, such as data lineage mapping and audit trails, ensure that decisions can be retraced to specific inputs and processes. In practice, transparency often requires a combination of internal measures and external disclosures. For example, a financial services firm may publish an annual transparency report while maintaining detailed internal records for regulators and auditors. ISO 42001 and NIST AI RMF recommend such structure methods, stressing the importance of tailoring disclosures to system risk levels. Embedding transparency into everyday practices enables organizations to shift from ad hoc disclosure to systematic governance, making openness a core part of responsible AI. Explainability relies on a set of technical and organizational methods that translate complex model behavior into understandable terms. Model-agnostic tools like LIME, Local Interpretable Model-Agnostic Explanations, and Shapley Additive Explanations, provide insights into feature importance, allowing stakeholders to see which variables influence a given outcome. Visualization techniques, such as heat maps, decision trees, or confidence distributions, make abstract patterns more interpretable. Rule-based approximations simplify complex models by generating decision rules that mimic system behavior while remaining human-readable. Counterfactual explanations show how small changes in input data could alter an outcome, helping individuals understand decisions at a practical level. Beyond technical tools, plain language communication is critical, translating findings into accessible narratives tailored to audiences. Organizationally, explainability requires policies, governance structures, and training to ensure consistent application across teams. Standards bodies emphasize both sides. ISO 42001 calls for explainability objectives and controls, while the EU AI Act demands user-facing explanations for high-risk systems. Explainability is thus achieved through technology and through intentional governance. One challenge in implementing transparency is finding the right balance between openness and the protection of sensitive information. Organizations must disclose enough about their AI systems to ensure accountability without exposing intellectual property, trade secrets, or security vulnerabilities. Excessive disclosure may invite adversarial attacks, such as model extraction or data poisoning, by providing malicious actors with insights into the system. On the other hand, insufficient disclosure undermines trust, compliance, and accountability. The solution lies in proportionate transparency, tailoring disclosures to the context, risk level, and stakeholder group. For example, regulators may require full documentation under confidentiality agreements, while end users may only need simplified explanations. ISO 42001 highlights proportionality as a guiding principle, requiring organizations to calibrate transparency against legitimate business and security concerns. Similarly, the EU AI Act balances mandatory transparency requirements with exemptions for security-sensitive information. Organizations should establish clear policies on what can and cannot be disclosed, supported by governance structures to review disclosure requests. By striking this balance, organizations can uphold transparency and explainability without compromising competitive advantage or exposing systems to unnecessary risks. Transparency must be applied consistently across every stage of the AI lifecycle, from conception to decommissioning. During the design phase, organizations should document objectives, system requirements, and ethical considerations. In the data collection and preparation phase, Transparency involves recording data sources, consent mechanisms, labeling processes, and potential biases. During model development, transparency requires documenting algorithm choices, training methods, validation tests, and trade-offs made in optimization. In the deployment phase, organizations must disclose system capabilities, limitations, and monitoring processes to users and regulators. Operation and monitoring demand ongoing reporting of performance, fairness metrics, and incident logs, ensuring transparency is maintained over time. Finally, during decommissioning, organizations should disclose data deletion, archiving, and lessons learned. ISO 42001 explicitly requires lifecycle-wide governance, integrating transparency at each stage as part of continuous improvement. The EU AI Act also mandates lifecycle-based transparency, particularly for high-risk systems, including clear communication of changes or updates. Explainability, like transparency, must be integrated across all stages of the AI lifecycle. During the design phase, organizations should define explainability objectives that align with user needs, regulatory expectations, and business goals. In data collection and preparation, explainability requires documenting how data features are selected, pre-processed, and justified for inclusion in the model. During model development, teams should adopt techniques such as feature attribution, interpretable algorithms, and testing for bias to ensure models remain explainable. At the deployment stage, explainability mechanisms such as dashboards, explanations in plain language, or visualization tools should accompany outputs so stakeholders can understand system behavior in real time. In operation and monitoring, organizations must review whether explanations remain accurate as data drifts or the environment changes. Finally, during decommissioning, explainability entails documenting lessons learned and ensuring that system behavior during its life cycle is preserved in records for future audits or accountability needs. ISO 42001 requires lifecycle-wide explainability objectives, while the NIST AI RMF emphasizes continuous monitoring of interpretability. A variety of tools and frameworks exist to help organizations achieve transparency. Model cards are standardized documentation templates that describe a model's intended use, limitations, performance metrics, and ethical considerations. Data sheets for datasets provide structured information about data collection methods, composition, labeling, and known biases. System logs and audit trails track decisions, inputs, and outputs, creating traceability across the lifecycle. Transparency reports, similar to those used by major tech companies, disclose statistics about AI usage, errors, or bias incidents. Third-party certifications and audits serve as independent verification that transparency obligations are met. Standards-based frameworks also support transparency. ISO 42001 prescribes structured documentation and reporting, while the EU AI Act requires disclosures tailored to system risk categories. Organizations may also adopt sector-specific frameworks, such as the FDA's reporting templates in healthcare or financial regulators' disclosure forms. Using these tools consistently ensures that transparency is embedded into governance practices. Explainability is supported by a range of technical and organizational tools. LIME, Local Interpretable Model-Agnostic Explanations, generates simplified, local approximations of model behavior to explain individual predictions. Shapley Additive Explanations provides mathematically grounded insights into feature contributions, offering both local and global interpretability. Counterfactual explanation tools show how changes in inputs could alter outcomes, helping users understand decisions in actionable terms. Visualization platforms display model reasoning through heat maps, decision trees, or feature importance charts. Beyond technical tools, frameworks like the NIST AI, RMF, and ISO 42001 emphasize explainability policies, requiring organizations to define objectives and provide explanations suited to stakeholders. Sector-specific guidance also plays a role. Financial regulators expect explainable credit scoring models, while healthcare regulators demand clarity for diagnostic AI tools. Explainability is most effective when tools are paired with governance mechanisms, such as review boards and plain language communication strategies. Combining interpretability techniques with structured governance will enable organizations to make sure explanations are technically accurate and also meaningful to diverse audiences, meeting both compliance and trustworthiness goals. Different stakeholders expect different levels of transparency from AI systems. End users expect to know when they're interacting with AI, what the system is capable of, and how decisions may affect them. Customers and clients expect organizations to disclose system reliability, accuracy metrics, and potential limitations. Employees and operators require transparency into workflows, monitoring mechanisms, and how AI impacts their roles. Regulators demand detailed documentation, disclosures, and compliance reports to verify alignment with legal and ethical standards. Auditors expect full access to system logs, governance records, and impact assessments to conduct evaluations. The general public increasingly expects organizations to be open about the societal risks and benefits of AI. Meeting these expectations requires audience-specific disclosures rather than a single, uniform approach. ISO 40-2001 requires organizations to align transparency with stakeholder needs, while the EU AI Act mandates explicit user-facing disclosures for high-risk systems. Just as with transparency, explainability must be adapted to the stakeholder's role and expertise. End users expect clear, plain language explanations that help them understand outcomes and, if necessary, challenge them. Business leaders and executives expect explanations that connect AI outputs to strategic goals, risks, and regulatory obligations. Developers and technical staff require detailed interpretability tools and metrics to refine and debug models. Auditors and regulators demand evidence that explanations are accurate, consistent, and sufficient for accountability. Society at large increasingly expects AI decisions, especially in critical areas such as healthcare or law enforcement, to be explainable to avoid arbitrary or biased outcomes. This tiered approach ensures that explanations are meaningful and appropriate without overburdening stakeholders with unnecessary detail. Both the NIST AI Risk Management Framework and ISO 42001 emphasize tailoring explainability objectives to specific audiences. Consider a financial services firm deploying an AI-driven credit scoring system. To ensure transparency, the organization develops model cards describing intended uses, training datasets, limitations, and known biases. Data sheets document sources of financial data, including demographic and credit bureau records, and disclose potential fairness concerns. The firm issues annual transparency reports that summarize approval and rejection rates, segmented by demographic groups, and publish them for both regulators and the public. Regulators receive full access to internal system logs, impact assessments, and monitoring dashboards, ensuring detailed oversight. Customers are notified explicitly when credit decisions are influenced by AI and are provided with a summary of the factors considered in the decision-making process. Implementing these transparency measures allows the organization to comply with financial regulations and build customer trust, as clients feel reassured that credit decisions are fair, accountable, and documented. This case study highlights how transparency practices can be operationalized in a high-stakes sector, reducing legal risks and strengthening the organization's credibility in the marketplace. A hospital adopts an AI tool to assist doctors in diagnosing rare diseases. To ensure explainability, the system integrates visual heat maps that highlight areas of medical images influencing predictions, helping physicians validate or question the AI's reasoning. Doctors also receive plain language summaries explaining which symptoms or test results contributed most to the suggested diagnosis. For regulators, The hospital maintains detailed technical documentation describing the model architecture, training data sources, and validation metrics. Patients are also informed when AI supports diagnostic decisions and are given the right to request an explanation in non-technical terms. Counterfactual explanations are employed. For example, showing that a diagnosis would likely change if a specific test result were different. Combining technical interpretability tools with audience-appropriate communication would allow the hospital to ensure that stakeholders at all levels can understand, trust, and validate AI decisions. This approach strengthens patient trust and ensures compliance with healthcare regulations requiring transparency and explainability. The case illustrates how explainability safeguards ethical obligations in life-critical environments where accountability is paramount. Transparency must be measurable to avoid becoming an abstract principle. Organizations can establish key performance indicators, KPIs, such as the percentage of AI systems with published model cards, the frequency of transparency reports, or the proportion of datasets with documented data sheets. Audit readiness scores can measure whether documentation meets regulatory and internal compliance requirements. Stakeholder feedback surveys can evaluate whether disclosures are meaningful and understandable. Tracking incident reporting rates can also show whether transparency mechanisms are effectively used. International standards recommend embedding these metrics into governance structures. ISO 42001 requires monitoring of transparency objectives, while NIST AI RMF suggests measurable practices for disclosure effectiveness. Measuring transparency provides organizations with proof of compliance and establishes clear benchmarks for ongoing improvement. Metrics also help identify gaps. For instance, if users consistently report that explanations are unclear, additional efforts may be required. Transparency must be approached not as a vague value, but as a measurable outcome with clear indicators and continuous monitoring. Explainability can also be evaluated using structure metrics. Fidelity metrics measure how well simplified explanations, such as decision trees or rules, approximate the behavior of complex models. Stability metrics assess whether explanations remain consistent across similar cases, ensuring reliability. Complexity measures evaluate how easy explanations are to understand. For example, the length of generated rules or the number of features highlighted. Human-centered evaluations, such as user studies, assess whether stakeholders actually understand and can act on explanations. In regulated industries, compliance audits may verify that explainability objectives have been met. ISO 42001 requires organizations to define explainability goals and monitor performance, while NIST AI RMF encourages human-centered evaluations of interpretability. By establishing KPIs for explainability, such as time taken by users to understand a decision or accuracy of user predictions after reading an explanation, organizations can validate whether their explainability measures are effective. Measuring explainability transforms it from an abstract aspiration into a concrete, auditable element of AI governance. Transparency does not happen automatically. It must be embedded into organizational governance structures. Policies should explicitly require transparency across the AI lifecycle, supported by procedures for documentation, disclosure, and stakeholder communication. Roles and responsibilities must be defined. Data scientists ensure data and model documentation. Compliance officers oversee regulatory reporting, and senior leadership approves public disclosures. Governance bodies, such as AI ethics committees or compliance boards, should regularly review transparency practices. Training programs must ensure employees understand their obligations and know how to create transparency documentation. Continuous monitoring processes should flag when disclosures are outdated or incomplete. ISO 42001 requires organizations to establish transparency objectives and governance mechanisms, ensuring accountability at all levels. The EU AI Act also assigns specific organizational responsibilities for user-facing disclosures. Explainability like transparency, requires strong governance. Policies must define explainability objectives, including which stakeholders need explanations and in what form. Development teams should be trained in using interpretability tools and communicating outputs in accessible terms. Governance boards or ethics committees should evaluate whether explanations are sufficient to meet ethical and regulatory expectations. Documentation should record which methods of explainability were applied, why they were chosen, and how they serve stakeholder needs. Continuous monitoring should test whether explanations remain accurate as models evolve. ISO 42001 embeds explainability into governance by requiring organizations to define and monitor related objectives, while the NIST AI RMF emphasizes human-centered validation of explanations. Governance for explainability also includes escalation paths. If stakeholders cannot understand explanations, there must be mechanisms for additional clarification or review. Implementing transparency is not without challenges. First, technical complexity makes it difficult to communicate how advanced AI models operate, especially deep learning systems. Second, resource constraints limit the ability of smaller organizations to produce detailed documentation and regular transparency reports. Third, legal and security concerns may restrict the amount of information that can be disclosed without compromising intellectual property or safety. Fourth, stakeholder diversity complicates the task, since disclosures must be tailored for different audiences without oversimplifying or overwhelming them. Fifth, dynamic systems present difficulties, as AI models that continuously learn or update may quickly render transparency documentation outdated. International frameworks acknowledge these challenges, but stress that they do not remove the obligation. Instead, organizations must adopt proportionate, risk-based approaches. ISO 42001 and the EU AI Act encourage organizations to balance transparency against legitimate constraints, while still ensuring accountability. Overcoming these challenges requires commitment, creativity, and governance structures that embed transparency into everyday operations. Explainability faces its own unique challenges, many tied to the technical and social nature of AI. Model complexity is a primary obstacle. Deep learning models often involve millions of parameters, making their reasoning difficult to translate into human understandable terms. Trade-offs between accuracy and interpretability also complicate implementation. Simpler, interpretable models may be less accurate than complex ones, forcing organizations to balance performance with explainability. Audience diversity presents another challenge. Explanations that satisfy data scientists may overwhelm end users, while simplified explanations may not meet regulatory expectations. Dynamic models that update with new data further complicate matters, as explanations must remain accurate over time. Resource limitations can also prevent organizations from investing in advanced interpretability tools or human-centered evaluation studies. Finally, there's a risk of oversimplification, providing explanations that are technically inaccurate but easier to understand, which can mislead stakeholders. International standards acknowledge these tensions, but stress that organizations must strive for proportional, risk-based approaches. ISO 42001 requires explainability objectives to be documented and monitored, while the NIST AI RMF emphasizes testing whether explanations are meaningful to actual users. Overcoming challenges requires balancing technical rigor with accessibility, investing in interpretability research, and building governance mechanisms to ensure explainability remains a living practice. The field of AI transparency is evolving rapidly, driven by technological advances, regulatory developments, and societal expectations. Automated documentation tools are emerging, capable of generating model cards, data sheets, and audit trails directly from development pipelines. Real-time transparency dashboards are being tested, providing continuous disclosure of AI performance, accuracy, and risk indicators. Regulatory bodies are also moving toward standardized transparency templates, ensuring consistency across industries and regions. Increased cross-border cooperation will likely lead to international harmonization of transparency requirements, reducing complexity for global organizations. Another key trend is the shift from reactive to proactive transparency, where disclosures are embedded into design processes rather than added after deployment. Organizations are also beginning to view transparency as a source of competitive advantage, highlighting openness as part of their brand identity. Standards like ISO 42001 will continue to refine requirements, while the EU AI Act will serve as a catalyst for industry-wide adoption. As transparency becomes more automated, structured, and standardized, it will shift from a compliance burden to an integrated element of responsible AI practice, strengthening trust and resilience across sectors. Explainability is also undergoing rapid innovation. Hybrid models are being developed that combine high-performing algorithms with interpretable components, reducing the trade-off between accuracy and transparency. Advanced interpretability tools, such as deep learning visualization methods and causal inference techniques, are making complex models more understandable. Interactive explanation systems allow stakeholders to query models directly, receiving tailored explanations suited to their level of expertise. Regulators are moving toward requiring explainability audits, where independent reviewers evaluate the adequacy of explanations provided to stakeholders. Another emerging trend is personalized explainability, where explanations are dynamically adapted to the preferences, literacy, and cultural context of individual users. Explainability is also becoming more tightly linked to fairness and accountability, with frameworks requiring that explanations demonstrate the absence of bias or discrimination. Standards like ISO 42001 will evolve to incorporate these advanced practices, while NIST and OECD guidance emphasize human-centered approaches. The future of explainability lies in more powerful tools and in embedding explanation into the very design of AI systems, ensuring that interpretability is a default property. These trends suggest that explainability will become increasingly practical, accessible, and integral to trustworthy AI. Transparency and explainability are not optional features of AI governance. They're essential pillars of trustworthy, accountable, and ethical AI. Transparency ensures that the design, data, processes, and outcomes of AI systems are open and visible to stakeholders. Explainability ensures that this information is meaningful, allowing people to understand, evaluate, and, if necessary, contest AI decisions. Transparency and explainability create the conditions for compliance, trust, and continuous improvement. Throughout this session, we have explored the definitions, benefits, risks of opacity, methods, tools, governance requirements, stakeholder expectations, measurement approaches, challenges, and future trends. Key lessons include the need to embed transparency and explainability across the AI lifecycle, tailor approaches to stakeholder needs, and balance openness with security and intellectual property. Standards like ISO 42001, NIST AI Risk Management Framework, and the EU AI Act set clear expectations, making these principles mandatory elements of responsible AI management. Looking forward, organizations that integrate transparency and explainability proactively will gain compliance, competitive advantage, stronger stakeholder trust, and long-term sustainability. This knowledge provides you with a strong foundation to aid you in the future, whether you apply it in your current role, pursue further study, or contribute to shaping responsible AI in your organization. By staying informed and engaged, you will play a vital role in ensuring AI develops in ways that are safe, ethical, and beneficial for society. Thank you for your time and your commitment to this learning journey. We encourage you to keep exploring and keep building toward a future where artificial intelligence serves the needs of humanity responsibly.